Okay, this lesson is about polynomial division. So we're going to talk about long division and synthetic division, but let's talk about long division first. So we're going to start off talking about long division with just numbers, since it might be a while since you've done long division. What you do with long division is you see how many times did 8 go into 5? And the answer is 0. Then you include the next number. How many times did 8 go into 56? 8 goes into 56 7 times. And then to check, the next step is you do 7 times 8 is 56. You subtract from here, and you get 0, or a remainder of 0, so the answer is 7. And also, that tells you that 7 and 8 are both factors of 56, since the remainder was 0. Okay, what about, let's do a different type problem. Let's say 223 divided by 8. Okay, so first you see how many times does 8 go into 22? The answer is twice. Then you do 2 times 8 gives you 16. You subtract. You bring down what's left. 22 minus 16 is 6. Then you bring down this 3, and you say how many times does 8 go into 63? 8 goes into 63 7 times. 7 times 8 is 56. If you subtract 56, you get 7. 8 goes into 7 0 times, so there's a remainder of 7. So 27 with a remainder of 7. And 8 is not a factor of 223, and neither is 27. So that's a reminder of how you do long division. Now let's start doing it with polynomials. How many times does x go into 2x squared? Well, if I said 2x squared over x, it's the same thing as 2 times x over x. One of these x's cancel, and you're left with 2x. 2x times x gives you 2x squared. If you subtract this, you get 0. There's a remainder of 0. What this means is both x and 2x are factors of 2x squared, and 2x squared divided by x gives you 2x. Now let's take this and do it with a longer polynomial. Divide x squared plus 3x minus 12 by x minus 3. Okay, this is a bit strange at first, but you'll get the hang of it. First, you just look at the first term, x squared, and you divide x squared by x minus 3. And the way you do that is you say how many times does x, this variable portion of the linear factor, how many times does x go into x squared? So you're asking this question, what's x squared over x? And the answer is x. Then you take x and you multiply it by this entire term. X times x gives you x squared. X times negative 3 gives you negative 3x. And then you subtract this. So if you subtract this entire term from the original polynomial that you're dividing from, it changes the sign on both terms. So I could write parentheses, or I could just change the sign on both. The x squareds cancel out as they should, and then you end up adding these two, and now you have the question 6x. How many times does x go into 6x? 6x divided by x is 6, positive 6, so you write plus 6. Then you multiply 6 times x minus 3, and you get 6x, and then 6 times negative 3 is minus 18. And you're going to subtract this, so you change the sign on both. You have to bring down the negative 12. The 6x's cancel out as they should, both of these 6x terms. And then negative 12 plus 12 gives you a positive 6. So that is your remainder of 6. So this is your answer. When you divide x squared plus 3x minus 12 by the linear factor x minus 3, you get x plus 6 with a remainder of 6. If you need extra help on a problem like that, you can, this will be on the extra help video. I'm going to do it one more time here, but to answer a slightly different question. Is this a factor? Remember, 8 times 7 was a factor of 56, because when you do 56 divided by 8, you get 7 with a remainder of 0. The same thing is true here. If I divide x squared plus 6x plus 8 by x plus 4, and I get 0, then as a remainder, then this is a factor. So let's do that. X goes into x squared, x times. You do x times x plus 4 and you get x squared plus 4x. Remember, we need to subtract this. So let me use the eraser. So if you're subtracting it, you change the sign on both. The x squareds cancel out as they should, and then we have 2x. How many times does x go into positive 2x? It goes in positive 2 times. Now we multiply 2 times x plus 4 and you get 2x plus 8. Let's bring down the plus 8. We're going to subtract this. If you do 2x plus 8 minus 2x plus 8, that's the same thing as minus 2x minus 8. You get 0, a remainder of 0. So x plus 4 is a factor of x squared plus 6x plus 8. What that means is x plus 4 times x plus 2 is equal to this. Okay, I'm going to do another one, but this time with a bit longer problem. Is x plus 4 a factor of x cubed plus 3x squared minus 6x minus 7? So that last question you might have been able to answer by factoring it, but we don't know how to factor this yet. So let's see if this is a factor. X goes into x cubed, x squared times. X squared times x plus 4 gives me x cubed plus 4x squared. I'm going to subtract this. X cubed minus x squared is 0. 3x squared minus 4x squared gives me a negative x squared. X goes into a negative x squared, negative x times. That's negative x squared over x is equal to negative x. Now I multiply negative x times x plus 4 and I get negative x squared minus 4x. Bring down the negative 6x. We're going to subtract this, so that changes both of these to positives. The x squareds cancel out and we're left with negative 2x. X goes into negative 2x negative 2 times. Multiply. Negative 2x minus 8. Bring down the negative 7. Subtract this, changes both signs again. The 2x's cancel out and we're left with a remainder of 1. So no, x plus 4 is not a factor of this polynomial. So the answer to this long question is no. It is not a factor. Okay, now we're going to talk about synthetic division. Synthetic division is an easier way to do what we were just doing. It gets rid of all the variables and you just deal with the numbers. So what you do is you rewrite all the variables, 3, negative 4, 2, negative 1. And then over here in the corner, you write the 0 that's associated with this factor. So if x plus 1 is a factor and it was a 0, it would be x plus 1 equals 0, so x would equal negative 1. So you write the opposite of the numeric part of the linear factor. Whatever would make this whole term equal to 0. So you bring down the 3, this is the first step, and then you multiply these two numbers. Negative 1 times 3 gives you a negative 3. And then you add these two. So this is really similar to what we did before. We said how many times does this go into something, and then we multiplied. You multiply here, and then you would subtract, but we don't have to subtract because we're doing the negative here. So you just add these two terms. Negative 4 plus negative 3 is negative 7. Then you multiply negative 1 times negative 7, it gives you a positive 7, and you add 9. Negative 1 times negative 9 is negative 9, and then you add, and you get negative 10. And if we look at this, the original degree was x cubed. We're dividing by x, so the degree goes down by 1 every time. So what this problem simplifies to is 3x squared minus 7x plus 9 with a remainder of negative 10. The x squared is the same thing as x cubed, just the degree is decreased by 1, and then you write, you fill in the rest. Okay, let me do another problem like that with synthetic division. So remember, you write the coefficients, 1, 4, 1, negative 6. You write the 0 that's associated with this factor. bring down the first number, multiply, and add. Multiply, and add. Multiply, and add. And now, this was x cubed, so this is x squared. This is plus 3x. This is minus 2 with a remainder of negative 4. So x squared plus 3x minus 2 with a remainder of negative 4. And that's what this one is. One more thing, you can use synthetic division to evaluate polynomial functions. There's a thing called the remainder theorem, and what it says is if you do synthetic division with any number that you would just plug into a polynomial, the remainder is what this what the value of the polynomial function is at that point. So let me go ahead and let's plug in negative 4. Let's evaluate this the old way. You would just plug in negative 4 for each term. For each x, anywhere there's an x, and then evaluate. Negative 4 to the 4th is 256. Negative 4 squared is 16. 4 times negative 4 is negative 16. So 5 times 16 is 80. So we got 256 minus 80 minus 16 plus 12. 256 minus 80 is going to be 170. It would be 176. Yeah, that's right. I don't know why that was hard for me to do in my head. Minus 16 plus 12. 176 minus 16 is 160 plus 12 is equal to 172. So p of negative 4 is equal to 172. Alright, now let's solve that with synthetic division. We need to write out all the coefficients, and if I did it like this, I would make a mistake, and here's why. The value for x cubed isn't shown. You go from x to the 4th to x squared. You skip x cubed. So if you're just writing it like this, without the variables, you would think this is x to the 4th minus 5x cubed plus 4x squared plus 12x, or is it just x cubed minus 5x squared plus 4x plus 12? It's neither of those, but it's confusing what it actually is, and that's because I've written it wrong. You have to include the x cubed term. The x cubed does have a coefficient. It's 0. The coefficient is 0, and that makes that term go away. So this is how you should actually write that out. Okay, wring down that number. You multiply negative 4 times 1, and you get negative 4. Notice I didn't change the sign on this because this is not a linear factor. This is just a value for x. So you just plug it in like this. You don't change the value. Okay, so you bring down the 1, multiply by negative 4, and then add. 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 And remember, the remainder is what it is evaluated to. All of that multiplication was easier. It was a lot easier than doing negative 4 to the 4th and adding all that stuff up. But not only was the calculation easier, it also gave me extra information. This is x cubed minus 4x squared plus 11x minus 40 with a remainder of 172. So this extra information is really useful, especially when that remainder is 0. If the remainder is 0, it means that this is a factor, and so not only do I have one factor, I would have two factors. So that's how you do synthetic division. I want you to pause the video and try and answer this. Okay, so using synthetic division, we found that p of negative 1 is equal to negative 69. You can pause the video and check out my work if you want to see how I did it. And that's it for this lesson.